Welcome to G Fun Facts Online. Imagine a time capsule the size of a continent sealed shut for over 30 million years. That's Antarctica. We see it as a vast, white desert of ice, but beneath that frozen shell lies a lost world. Hidden in permanent darkness are the ghosts of enormous river systems, sprawling coastal plains, and lakes bigger than any you've seen, all from a time before the ice. Today, we're going on a journey beneath the ice to unearth Antarctica's ghostly waterways and explore a greener, wetter past that has profound implications for our future. For decades, the land under Antarctica's ice sheets, which are kilometers thick in places, was a complete mystery. Scientists could only guess what lay beneath. But thanks to some incredible technology, we've started to peel back that icy curtain, and what we're finding is far from the flat, boring landscape many imagined. The first major challenge was simply seeing through the ice. The primary tool that made this possible is called ice-penetrating radar, or IPR. Think of it like a powerful fish finder for a continent. An aircraft flies over the ice sheet, sending radio waves down. These waves travel through the ice, bounce off the rock and water below, and return to the aircraft. By timing these echoes, scientists can build incredibly detailed 3D maps of the subglacial world. It's how we've discovered ancient valleys, hidden mountain ranges, and vast plains with stunning precision. These radar surveys have been compiled into massive datasets, like one called BedMap, which gives us a comprehensive atlas of this hidden continent. But radar can't tell us everything. To confirm if there's liquid water down there and how deep it is, researchers turn to seismic surveys. They create small, controlled explosions on the surface and listen to the sound waves that travel down through the ice. The way these sound waves travel and reflect back tells a specific story. Liquid water has a distinct seismic signature, allowing scientists to not only find subglacial lakes, but also to get an idea of the sediment layers at their bottom. Adding another layer to our vision are satellites. From orbit, satellites with radar and laser altimeters can measure the height of the ice surface with incredible accuracy. They can detect subtle changes, a rise or fall of just a few meters over a vast area. What could cause a continent-sized ice sheet to breathe like this? The filling and draining of massive lakes hidden underneath. Satellites can also measure tiny variations in Earth's gravity, which helps reveal the large-scale geology and structures buried deep beneath the ice. The sheer volume of data from all these sources is staggering. To make sense of it all, scientists are now using machine learning and artificial intelligence. AI algorithms can sift through petabytes of data, identifying subtle patterns and features in the subglacial landscape that a human might miss, dramatically speeding up the pace of discovery. So what has all this technology revealed? One of the most breathtaking discoveries is a vast, ancient coastal plain hidden under the East Antarctic ice sheet. This landscape, larger than many countries, is remarkably flat and is believed to have been carved by huge rivers between 34 and 80 million years ago, long before the continent froze over. This ancient river-carved world has been preserved, almost perfectly, for over 30 million years. These ancient riverbeds are not just historical curiosities. They actively shape the behavior of the ice today. The deep troughs carved by the old rivers now act as superhighways for modern glaciers, channeling ice flow towards the ocean at faster speeds. In contrast, the flatter, elevated areas between these river valleys seem to slow the ice down. Understanding this ancient plumbing system is absolutely critical if we want to predict how the Antarctic ice sheet will respond to a warming climate and how much it might contribute to future sea level rise. But it's not just ancient rivers. Scientists have now cataloged over 400 subglacial lakes scattered beneath the ice. And these aren't small ponds. The most famous is Lake Vostok in East Antarctica. It's one of the largest lakes on Earth, with a surface area of about 12,500 square kilometers. and a depth of over 500 meters in places. For a long time, it was thought the water in Lake Vostok had been isolated for millions of years, a pristine sample of a prehistoric world. More recent research suggests its water is slowly replaced by the melting and refreezing of the ice sheet above it, with a full cycle taking about 13,000 years. Still, that's incredibly ancient water. Some of these lakes are described as active. This means they fill up and drain over time, connected by a complex network of subglacial rivers and channels. This creates a massive plumbing system at the base of the ice sheet. When a lake drains, it sends a huge pulse of water downstream, which can lubricate the base of the glacier above it, causing it to suddenly speed up its journey towards the sea. This dynamic hydrology is a key factor in the stability of the entire ice sheet. The existence of these massive river systems is definitive proof that Antarctica wasn't always a frozen wasteland. To understand this watery past, we have to go back in time, to when the world map looked very different. For much of its history, Antarctica was part of the supercontinent Gondwana, nestled alongside future South America, Africa, India, and Australia. During the age of dinosaurs, even though Antarctica was near the South Pole, it had a temperate, even subtropical climate. Why? Because the concentration of carbon dioxide in the atmosphere was much higher, creating a powerful greenhouse effect that kept the whole planet warm. About 180 million years ago, Gondwana started to break apart. The final, critical separation for Antarctica happened around 34 million years ago, when it broke away from South America. This opened up the Drake Passage, a deep channel of water between the two continents. This event was a climate game-changer. It allowed for the formation of the Antarctic Circumpolar Current, a powerful ocean current that circles the entire continent, acting like a thermal barrier, isolating Antarctica from warmer waters to the north. This, combined with a global drop in CO2 levels, plunged the continent into a deep freeze, triggering the formation of the massive ice sheets we see today. But before that big freeze, Antarctica was a land of flowing water and abundant life. Fossil evidence is stunning. Scientists have found fossils of polar forests that grew at latitudes as high as 85 degrees south. In a region called the McMurdo Dry Valleys, which is now one of the coldest, driest, and most inhospitable places on Earth, there's evidence that the area was once warm and wet enough to support liverworts, mosses, and even small, shrubby trees. This green vegetation thrived until about 14 million years ago, and liquid water was present for even longer, until about 6 million years ago. So why does studying this ancient paleohydrology matter so much today? It's far more than just geological history. It holds vital clues for our future. As we've seen, the ancient river systems and plains under the ice directly influence how that ice flows. By feeding the detailed maps of this subglacial landscape into our climate models, scientists can make much more accurate predictions about how the ice sheet will respond to a warming world. This is incredibly important because the East Antarctic ice sheet alone holds enough water to raise global sea levels by a staggering 52 meters. Understanding its stability is one of the most urgent questions in climate science. There is another fascinating implication. These subglacial lakes, dark, cold, high-pressure environments isolated for thousands of years, are considered unique analogs for extraterrestrial life. If life can exist in the crushing darkness beneath Antarctica's ice, it might give us clues about the potential for life on other icy worlds in our solar system, like Jupiter's moon Europa or Saturn's moon Enceladus, both of which are thought to have liquid water oceans beneath their icy shells. The exploration is far from over. Major international projects are constantly deploying new technology to map this unseen world in even greater detail. The next great frontier will likely involve drilling through kilometers of ice to collect rock and sediment samples directly from these ancient riverbeds and lakes. Imagine the stories those samples could tell. They could contain preserved organic matter, pollen, spores, maybe even DNA, giving us an unprecedented high-definition window into the lost world of a green Antarctica. The ghostly rivers of Antarctica, silent for millions of years under a blanket of ice, are finally beginning to speak. They tell a story of a planet that is dynamic and constantly changing. They remind us that the frozen continent at the bottom of the world was not always frozen, and its deep past contains a roadmap that can help us navigate our planet's future.